Um, you may be more familiar with this topic as, oh yeah, all that rubbish about the alphas and the betas and the minus B on A, blah blah blah. Sum and product of roots. Okay, so I keep on telling you, right, this topic, polynomials, much of it is quadratics but on steroids, and it's no more obvious than here. So before we get onto the real polynomials, and the reason why I'm calling it Vieta's result and not just sum and product of roots, let's just revise what you learned from year 10, which is that you can get a relationship between the roots of a quadratic and the coefficients of the quadratic. Okay, one defines the other, right? So if we say, right, a quadratic equation right? If you remember back, there was a whole little subtopic on constructing quadratic equations and polynomials, right? So if you know what the roots of quadratic are, you know, you could factorize it in this way. Okay? However, we also say normally that, sorry, I should actually have an A over here. Because you remember, right, if I said, say the roots of 1 and 2, x equals 1 and x equals 2, then this equation here would satisfy that. It would have roots at x equals 1 and x equals 2, but if I put a 3 at the front, it would still have the same roots, and if I put a minus 3 at the front, it would still have the same roots. What difference would it have if it's going to have the same roots? Yeah. So how stretched out or how squashed it is. So if I put it at 1 and 2, right? So put 1 and 2 there. That's a terrible scale, but you get the idea. You might have one parabola like this, or you might have one like this, or one like this, and they all still satisfy this condition that we're given it, right? So therefore, that's why I put an A out the front. Now, these are the roots. What about the coefficients? Well, the customary way of writing the general form of a quadratic equation looks like so, right? So in order to get the relationship out in the most obvious way, there's a couple ways to do it. But I could divide through by A, and that would give me this. Okay? And then in a very similar way to how we did it with auxiliary angle, right? I'm going to expand one side, except instead of a trig expansion, I just got algebra, right? And then I'm going to compare my coefficients. Do you remember how we did that with auxiliary angle? So let's go ahead and do it. What am I going to get here? Let's see here. X squared minus beta x minus alpha x. Okay? So there's just my expansion. And now I just want to write it in a form that makes my comparison of coefficients the most direct. Right? So that x squared at the front, no probs. Now I'm going to have a b on a here. And that's with the x term. Okay? So here are my x terms. So if I slap a minus sign at the front, that's where my sum of roots comes from. And there's my product already hanging over on the end. Okay, so by comparison of coefficients. What do we got here? Well, minus the sum of roots. That gives you B on A, which gives you this more familiar result. And likewise, or similarly, the product is so. Okay? Now, it's worth mentioning that you could do exactly the same thing by taking these two results, right, and saying, well, I know what those roots are going to be. If this is my quadratic equation, okay, then I can use the quadratic formula and say alpha is going to be this root, and beta is going to be the other one. And you can verify this result, these two results down here, which are the first of Vieta's results. You can verify them by literally adding them together, and you'll get this. Can you see it, by the way? When you add them together, because they're conjugates, right? This minus and this plus will cancel. You'll get minus 2b on 2a et voila, right? And get it, French? Anyway, and here, okay, you multiply, and again, because it's difference of squares, right? This b, well, minus b, and this b squared, they're also going to cancel out. So you're going to end up with 4ac on 4a squared. 4ac on 4a squared, because you multiplied out, right? And you can see cancel, 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 cancel. C on A, right? So you could go either of those methods and get your results, okay? Now what I'd like you to do, even though you can probably sort of anticipate it, but we do need to be able to prove it, okay, is to raise it up 1 power. So if I put the degree up to 3, I'm not going to get a quadratic equation. I'm going to have a cubic equation with roots alpha, beta, and gamma, okay? Actually, like, I've seen gamma written like 10 different ways, okay? So just write something that looks vaguely recognizable and doesn't look like any other letter, but you're going to confuse it, okay? Yeah.
Is there a C degree power?
It's the third letter, yes. Well, I guess it's gamma. Gamma is that's the name. Yeah, well, that's what happens when you're ancient. And anyway, what I'd like you to do right now in the next 5 minutes is rehearse the way that we did this for quadratics. Okay, would you do it for cubics as well? Okay, so your first line is going to look like this, except you're also going to have an x minus gamma here, right? And your right hand side is going to look much the same, except it'll be x cubed, bx squared, cx, and d. Okay, and then go through and do the same. Okay, and we'll catch up in a couple of minutes.